Hello and welcome to my YouTube video. Today I'm going to show you how to do the wiring for the Zionsville electric fan conversion on a 2003 BMW 530i. I installed this brand new all aluminum radiator from Zionsville, and it comes with a Spall electric fan and a shroud as well. This is where the overfill tank is, and they also include a radiator cap for you. The wiring is pretty simple once you understand how it all works. It took me quite a while. I had the help of my friend and also Jim Malev on Beamer forums. So right here you have a 12-volt battery source, which is the positive terminal. You use a yellow wire that goes to a 30 amp fuse and goes back into the yellow wire into a solder point where it separates into a high-speed relay and a low-speed relay. So the high-speed relay is the easiest one. Eventually it spits out a gray wire, which is the sensor wire, and it goes down here and goes to the high pin of the temperature switch, which is T2, and the T1 is the low speed signal. We also have the low speed relay. So what's different with the low speed relay is that it uses a resistor. And keep in mind, a red wire comes out of these relays as well with the gray wire. So right now I'm going to show the gray wire. It goes down and into the T1 of the temperature switch. So both the relays have red wires, and like I said, with the high speed relay, the red wire just goes to a solder point, and then for the low speed it hits a resistor, and then it comes out with a separate red wire, and then you solder it. So I'm going to show it to you right here. So this is where both red wires meet, and you solder them together to go to this connection point. You make it a connection right here. You basically becomes one single red wire. And keep in mind, the black wire in this connection point is actually the negative that goes directly to a ground post where an OEM relay sits. So this will work for a 525 or a 530i M54 from 2001 to 2003. Just this setup specifically because I do not have an OBD2 port here that's seen in the earlier models. So we had to find a different source of the 12 volt when the ignition is on. So it goes to a temperature switch in the fuse box. And I'll show you a video of it right now of how it looks like. So here's the temperature switch on the bottom right. So if you look at point number 2, which is the rightmost pin, the green and white wire, that's where I use the T-tap connector. So technically you are splicing, however it's a very tight splice, and there's basically no room for error with this. You just use one of those T-tap connectors. I bought one from Amazon, like this whole kit. I used this specific gauge size as well, and it just made a very tight connection with the orange wire. So that way you can have the fan running when you just have ignition on, just to cool down the engine after a long drive in the garage. I have researched this as well, and some people actually do use the starter as a source. However, I find this the best location in my opinion, mainly because it's a much cleaner tuck. You won't have wires running around your whole engine and risk overheating a wire and, making it look a little ghetto. And I highly encourage you to use the shrink wrap fleece for all of these wirings. That way you can prevent any shorts. God forbid it's too hot and it melts away, which it shouldn't be an issue, but it's just a precaution. Better be safe than sorry, like I say. So then the orange wire goes to the low speed relay, and that's how you're able to use the low speed fan when the car is technically on ignition on, in case you need to cool down your car. So let's start with the wiring. We have the yellow wire here connected to the positive battery terminal. That's always on. used the fleece shrink wrap, went under this rubber boot tunnel and into the windshield cowl, wrapped it all the way down here, and it goes into the fuse box through a very small hole. I made sure it's airtight as well, so that way no moisture goes in, and you'll see the wiring go down here through the fuse box, and then it goes down here. This is not a split with the wirings. Don't be worried. I'll show you how it goes. It goes down here into the fender, and it's connected by these two nuts. And I painted it the same body color so it looks OEM as much as possible. Comes back out through the same path, by the way, and splits here. This is where the red wires go, with red and gray go here. By the way, this is the red and gray highway, as you want to say. It splits here. The red goes down there. Well, one of the reds, because there's a resistor there. And I'll show a picture of how it looks like. This is an OEM hole found in the 530i's. And it goes down here under the fender liner. Let me show you a picture right now. So this is where the red wire goes to for the low speed relay. And it comes out and out through the hole again. So to make sure this stays on, I used double-sided extreme tape from 3M. And I do know I'm gonna get some hate for using double-sided tape. However, I found this the best option instead of using stud welds into the frame. And I've checked on it from time to time, and it's still sticking on very strong. You can use some stud welds. However, if, for example, the resistor goes bad, it will be much harder to replace if the resistor goes bad. And also you risk damaging the resistor if you weld or use a stud welder on this. So let's continue regarding the red wires and the gray signal wires. So the gray signal wires are to the right, and the red wires are to the left, the ones that can provide power. So the grays go here to the temperature switch, right here. Remember, lows T1 and highest T2. The red wires go around here. I've had them soldered here under the headlight, and they run all the way to here. I did it this way so that way it's hidden and you won't see too much wiring. And so I'll show you where the black wire goes. The black wire actually connects from the temperature switch as the main feed, and I had it connected to this ground post right here where the OEM relay sits. This ground post is strong enough to withstand the power and create a loop for electricity to travel to. And this will ensure that the whole fan system works. The only issue I've had was using the temperature switch because Zionsville sent me a faulty one. However, they were able to send me a properly working one after. It was just one little delay. Now, a lot of people use the temperature switch down there with some silicone pieces connected. However, for me, it wouldn't make a difference if it's between the fins of the radiator or on the tubes. I prefer just using Zionsville's setup because I haven't heard any complaints regarding that. Because eventually all the coolant is going to heat up and the heat through coolant travels pretty equally. But it's to each their own. There's debates about it. I just used the fins that Zionsville recommended. So here's a video of it working in action outside. This is on the low speed setting because it's not hot enough. You'll find out that for it to go into high speed, it's got to be pretty hot outside, and you really have to be pushing your engine to the limits. When I was filming this video, it was 18 Celsius outside, which would be converted to around 65 Fahrenheit in the very cold California winter. Here's a video clip of just the key being turned to ignition on and the fan running to help cool down the engine a little bit more. And lastly, I'll show you how we can test the temperature switch sensor if it's not working properly. we put it into 200 ohms. We're using this voltmeter to see if both T1 and T2 pins work or not. So usually when it's working, you shouldn't see resistance. So this is the main feed in the middle, and to the top left and top right are the T1 and T2 pins. So I'll show you how we can do this. So we'll put the negative onto the main feed, and we'll put the positive onto either T1 or T2. I skipped through the video portion of where I was struggling, but as you can tell with the T1, there is resistance and it's just jumping around, and there shouldn't be any values when you test it. See, I'm testing T2 and there's nothing. But when I test T1, we have abnormal values. So therefore, this sensor was actually broken and Zionsville had to send me a new one. So that is the end of my video. I will provide all of the parts numbers below in the description. I will also provide a PDF file of the wiring diagram that I made. I try to make it as simple as possible. If you have any questions, feel free to comment below. I'll do my best to answer them. And I will provide any and all forum links that I have used for this project as well. And on that bombshell, it's time to end the video. Thank you for watching and have a great night. Bye-bye.